Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to everyone. Okay, so how's everyone today, this afternoon?
Fine, madam.
Okay,
Fine,
thank you.
madam.
Good. Okay, before I start, let me just again remind you regarding your assignment 2. Okay, so assignment 2, I hope that everyone has already downloaded questions. And again, please follow the deadline, which is on which is on December 25th, all right, during Christmas on Friday, okay, by 5 p.m. And again, I would like to remind that you don't wait until last minute to submit. If you have finished doing your assignment, then you can just upload your assignment, all right? Okay, and again, make sure that you are doing it again in a group, okay, a group of 3 to 5 people like last time, and don't forget to also submit the individual assignment as well, okay, to the group leader or group rep, all right? Okay, and another thing that I would like to inform you is regarding the video that I've already actually, because due to some technical problem last week to certain people where they couldn't hear my voice, all right, and they couldn't actually see what's on the screen. So I actually decided to actually upload the video. Basically, I'll just put the link, all right, to the video. So the link is already under week 10. Okay, week 10 in ULearn. So if you would like to actually watch it again, so you can just go to ULearn and click the link there. All right. Okay. So that is that one is actually for chapter 3. Okay, last week on application of trigonometry. Okay. All right. So I think that what I'm going to do today. All right. You are supposed to try one questions. All right. On application of trigonometry, we have like one question that we are going to discuss, but I hope that you all have done it so that you can compare your answer, right, with what I'm going to write. Okay, but before that, anybody got any questions before I start the lecture today? Let me just share the screen. Okay, but anybody got any question to ask?
Madam, what about the test mark, madam?
Yeah. Yes.
Yeah, about test marks, yeah.
About what? Caution?
Yeah, about the test marks.
I cannot hear you. Can you speak louder, Caution?
Hello?
Yeah, okay.
Hello?
That's better. Yes, yes, I can hear you.
Madam, how about the test, madam, we did?
Test.
Yeah.
Oh, okay. I'm still marking actually. I'm still in the midst of marking the test paper. Actually I just started. Okay, just started marking yesterday. So I hope that I'm able to finish hopefully by next week, because it's everything is on the soft copy. So actually marking soft copy is actually is quite well, in a way it's like a bit tedious, all right, because it's not like if it is a script, hard copy script, then it's different. Okay, but anyway, I think it is early for me to say overall the performance because I haven't really marked many scripts yet. Okay, so wait until next week after I finish marking, then only perhaps we can I will talk about it, all right, talk about the performance, all right. But in the meantime, for your assignment 1, just to inform everyone, assignment 1 marks I've already key in the system. It's just that I do not know whether you are able to see or not, or check. I'm not so sure, okay, about that. uh, if you know, maybe you can try. All right, go to the portal. Maybe under the SMP. I'm not so sure how can you actually check your marks, because I've already key in marks into the system. So I'm not so sure. Maybe later I'll find out for you. How do you actually would like to check your marks? Okay. Assignment, yes, assignment 1, because I have finished marking. I mean, a few weeks ago, and I've already keyed in marks in the system. Okay, so marks for assignment is there. So that means if you are able to check that assignment marks is actually is what you can see is actually is upon 10%. Okay, upon 10% of assignment marks. Okay, assignment 1. Okay, and for test, because I'm still in the midst of marking, so all right, I haven't finished marking. So by the time I finish, then maybe I'll talk about it. Okay, Kaushan? All right.
Yeah, okay, thank you, madam.
Okay. Okay. Can we continue? Can we look at this question now? Can you all see the questions? Okay, this is the question that you were supposed to do over the weekend. I hope everyone tried, okay, the question so that you can compare, all right, the answer today. This is actually is application of trigonometry. Okay, if you read the question carefully, all right, it's about a plane is flying over a highway at an altitude of 6,000 feet. A blue car is traveling on a highway in front of the plane, and a white car is on the highway behind the plane. So the angle of elevation from the blue car is to the plane is 45 degrees. So if the cars are 2 miles apart, how far is the plane from each car? So there's a hint, all right, which says that consider the triangle formed by the cars and plane as two right triangles that share the same lake. Okay, that shares a lake or the same lake. And note that 1 mile equals 5,280 feet. Okay, now if you look at the question carefully, there's a diagram as well. Okay, and the fact that this is the blue car is here. Okay, this is the white car, and this is a plane. And from the question, it mentioned that okay, the altitude, the height. Okay, altitude is the height. All right, a plane is flying over a highway at an altitude of 6,000 feet. So the height, all right, is 6,000 feet here. And a blue car is traveling on highway in front of the plane. So this is a blue car. All right, so that means basically the plane is going this way. All right. Okay, and then you are given in the question is about the angle elevation. Okay, so this is the angle elevation from the blue car to the plane is 45 degrees. And the cars, these two cars are 2 miles apart. Okay, so question is actually ask you to find how far is the plane from each car. That means question is asking for this distance, all right, the distance between blue car to the plane as well as the distance from the white car to the plane. So basically question is asking for this distance, two distance, okay, from these triangles. And the question also mentioned about these triangles here are the right angles. Okay, these two are right angle triangles. Okay, all right, so if these are the right angle triangle, okay, all right, then if it is a right angle triangle, later on you can actually use trigonometric ratios, okay, to find perhaps certain length, all right, or angle, whatever. Okay, but when it mentioned about two right triangles or two right angle triangles, so that means we can actually use certain trigonometric ratios like sine, cosine, tangent, secant, cosecant, cotangent. Okay, but if we look at like one big triangle like this is what we call oblique triangle. So if it is oblique triangles, then we have learned that previously, if we want to find angles or we want to find side for an oblique triangles, then we have law of sine as well as law of cosine, okay, that we are going to apply. Okay, so basically what we can actually find first is this length, isn't it? Okay, so we can actually find the W first, because the fact that this is a right angle triangle, okay, right angle triangle, and we are given this is 45 degrees, okay, the angle elevation, all right, from blue car to the plane is 45 degrees, and the height here is also given, okay, so the height here is also given as 6,000 feet. So we can find this length here, the distance, all right, from the blue car to the plane, in which we denoted here by W from the diagram. So we can just simply use what we call our trigonometric ratios, okay, because we have angle here. So then this is our opposite, and this is our hypotenuse for the right angle triangle. Okay, right angle triangle, this is hypotenuse. This is opposite and this is angle. So then we have actually one trigonometric ratios that we can form. All right. So in this case is where we can say that sine 45 degrees equals to 6,000. All right. 6,000 feet over W. Okay. So we can actually find W first in this case. All right. So W then is equal to, we have our 6,000 divided by sine 45 degrees. Okay, so sine 45 degrees is 1 over sec 2. You can use calculator, all right, or you can give us in terms of exact value. So it doesn't matter. In this case, it doesn't mention, all right. But if it mention about exact value, so you have to give us in terms of exact value. Okay, the scripts. Okay, maybe I can just say something about our test script. The test, if you remember the test, all right, you have a question on trigonometry where a question asks you for exact value. Okay, but so far the one that I've marked, all right, majority actually gave us in terms of decimal. You simply like use calculator and compute. So that is actually is wrong. Okay, it's totally wrong for that particular question. Okay, if you remember, that's where you have a question on trigonometry asks you to evaluate and find exact value. So when the moment you use calculator, straight away it's wrong. Okay, so no marks will be given for that. All right, because definitely you are going to get decimal. So if question say exact value, you give us decimal, then it's definitely it's wrong. Okay. So like this question, it doesn't mention. So you can just give us in terms of exact value, or even you give us in terms of decimal, no problem. But something like this, maybe it's much easier and faster if you can just use calculator. And if you do that, roughly you'll get something like, okay, 8,084.85. Maybe if I use one decimal, I'll give just one decimal place, 8,485.3, and this is feet. Okay, so this is our W. Okay, so once we know our W, all right, we also knows this distance there, 2 miles. All right, and that 2 miles perhaps we can change into, all right, we can change that 2 miles into feet, right? Because we are given here, all right, that 1 mile equals 5,280 feet. So that means this distance basically is the same as 2 times 5. Okay, 2 times 5, 5280. Okay, so which is this is actually is 10,560. So we know this length. Okay, so we know this length. So that means now we know this. All right, we know this length. This angle is given, and we also know this length. So what we want now is this. We want this. So now we are looking at a bigger triangle. This one big triangle, which is what we call the oblique triangle. Okay, oblique triangle. And remember, side, angle, side are known. S, A, S, side, angle, side. So this angle is included angle. So when you are given side, angle, side, included angle here. So if we want to find this length here, then we are going to apply our what we call law of cosine. Okay, so to find the B, all right, so basically we are going to use our law of cosine. So by law of cosine, okay, we can establish our identity like this, all right, that B squared, all right, if I'm referring to the diagram here, so B squared equals to, all right, doesn't matter how you write it. So maybe I can just write it as like W squared and then plus 10,560 squared minus 2W and then 10,000. Of course, later on I'm going to substitute my W from what I've already gotten. Okay, times cosine and then 45 degrees. Okay, I'm running out of space. Okay, cosine 45 degrees. Okay, so this is our law of cosine. So in other words, okay, so B would be our square root, a big square root. Okay, now I can substitute the value. W is 8485.3 squared plus 10,560 squared minus 2 times 8485.3. Okay, I don't have enough space here, but I hope you understand. This is going to be multiplication of 10,560 times cosine 45 degrees. Okay, so this is what you need to compute. Okay, again by using your calculator. All right, by using your calculator. Okay, roughly, all right, in terms of perhaps one decimal place again, you'll get 7536.2. Okay, so this is, in this case, all right, is length here. Okay, so this is our B here. This is the one that we want. Okay, again, so that is B. So once you have found this, you got these two answers, then you can conclude. So maybe I can conclude, therefore, the plane is about 8,485 feet from the blue car and about 7,536 feet from the white car. So that will be my conclusion. Okay, so you got the same answer as mine? Everybody got the same answer? Anybody got differently? Or anybody got any question to ask? All right, okay? Okay, everyone? Any question? No? Understood? All
Yes,
right,
madam.
is it understood? Okay, I really hope you do. Okay, because so far when I mark your, test paper, it's not that many script yet, but so far when I mark, as if it's like you don't understand what we were like talking during our session. Okay, all right. So it was quite sad actually so far when I mark the paper. Mark the script. Okay, but it's still early to tell because as I said, I just started marking yesterday. So far I've already marked only about like 20 scripts only out of 100 over. Okay, all right. Okay, so I really hope you do understand, and I really hope that after this, you try, please try all the questions, all right? All the question and the exercises in the book, all right? Whether it's exercises for each section or chapter exercises at the end of the chapter. So please try all questions, all right? Please try all questions. Maybe during tutorial, we may not have enough time to discuss all. Okay, but I will try my best to actually discuss almost all questions.
Madam. Madam, we cannot hear you.
Hello, madam.
Does Madam hear us? I think she's not.
Madam, actually, she, yeah,
Okay.
Madam. Hello, madam.
Can you hear me now?
Yes.
All right. Okay. I
Yes,
think
Madam.
there's something wrong with the playbacks. Suddenly,
Yeah.
my screen also stuck. It doesn't move. All right. Okay. Let me share again the content. Okay. Can you all see now?
Yes, Madam. Madam, can I ask
Yes. Sure.
from the question before?
Okay. Yeah. Sure.
Uh,
This question.
yeah. The b square equals to w square.
Okay.
Is that a formula?
Yes. It's a formula for law of cosine. It's a formula of law of cosine where you have law of cosine. Basically, you have a triangle where you have ABC. All right, you have ABC, and then this is small a, small b, and small c. So you have something like that. Okay, so you have, like, if you want to find the b squared is a squared plus c squared minus 2ac cosine b. This is one formula. If you want to find a, all right, so a squared equals b squared plus c squared minus 2 bc cosine a. Basically, if you look at the formula, it is regarding this oblique triangle. Okay, it is regarding this oblique triangle. So this, if let's say you want to find b, you want to find this, all right, it will be the length here squared plus this length here squared minus 2 times a times c, and then cosine b. The angle is actually what we call the included angle. All right, so this is actually is the law of cosine. So if you refer to the slide, okay, you have the previous slide. Okay, you have actually this That. Okay, this is actually is the law. Okay, it's just that now if I'm referring to our triangle just now, I'm using a different letter like W, the B. Okay, but basically it's the same thing. Okay.
Okay, madam. Thank you.
All right. Okay. All right. Okay. Any more question before we start with the new chapter? Any more question? All right. If not, then perhaps we move on to the next chapter. This is our chapter 4, which is about complex number. All right. Okay. For chapter 4 or complex numbers. Okay. I hope also that this is not something new. Perhaps you also have done this before, you have looked at this before, or you have encountered this before. So hopefully that this is also a refresher course, all right, to you. But if it is like your first time, okay, learning about complex number, so please really pay attention. And if you do not understand, okay, you please ask, just interrupt. Okay, let's look at the objectives as well as what are the contents for this chapter. All right, so basically for this chapter, at the end of this session or at the end of the chapter, all right, we hope that you are able to express what we call complex numbers in polar form, all right, and also in exponential form. Okay, beside the rectangular form, all right, so you also have polar form later on as well as exponential form. And then you are able to find what we call products and quotient of complex form in polar form. Okay, complex numbers in polar form, as well as using this theorem, what we call the De Moivre's theorem. All right, to find complex number with powers. Okay, and there are about like 6 sections, all right, or 6 subtopics for this chapter. So this chapter is also quite big, all right, in the sense that there are so many stuffs, all right, happening in this chapter, all right. That you have what we call complex number and the properties, all right, which we are going to introduce you today, as well as polar coordinates, and then you have polar form of a complex numbers, exponential form of a complex number, or Euler's formula we call it, product and quotient of complex numbers, two complex numbers, as well as the last one is where using the De Moivre's theorem to find powers, okay, for powers or exponent for complex number. Okay, now the word itself is actually complex, okay, so complex, so it's quite difficult, okay, it's complex, all right, so something which is not like usual, okay, it's not like usual. Okay, so our usual numbers maybe like this, okay, like this number, all these numerals, all right, so you have your this is all what we call real numbers, right? 1 2 3 minus 1, all these are what we call real numbers. Basically real numbers, all right, if you remember, real numbers are numbers on your x-axis. So if you look at if you refer to your x-axis, okay, numbers on the x-axis, all right, numbers on the x-axis going from minus infinity to positive infinity, all right, these are what we call real numbers. Okay, these are what we call real numbers. Okay, from minus infinity to positive infinity, these are what we call real numbers. So any numbers on your x-axis from minus infinity to positive infinity are real numbers. Okay, so why there's such complex numbers? All right, why do you need to learn about complex numbers? Okay, this actually complex number came along when people would like to try to solve certain equation, especially quadratic equation, all right, in which the solution, okay, the solution for quadratic equation involved with square root of a negative number. Okay, for example, a simple example, right, you have such equation, x squared equals to minus 1. Okay, x squared equals to minus 1. So which means that if you want to find the x, you are going to take a square root on the right hand side. So what you have is actually on the right hand side is a square root of minus number, or negative 1 in this case. Okay, so this is actually is the basis, all right, the basis of where mathematician, all right, they invented this complex number, all right, to take care of such equation, okay, to take care of this type of equation. Because previously, if you remember, when you learn about quadratic equation, all right, when you solve for quadratic equation previously, when it comes to this type of solution, then last time we would say, okay, if we have something like square root of a negative number, then we will say, okay, therefore no real solution. We would say like that. All right, either you say undefined, because you cannot compute, all right, or you can say no real solution, because there is no numbers in which you square you get -1. Okay, this statement x square equals to -1 means that you have one number where you square you got -1. Definitely there's no such number, because if you put this x as a positive value, you square it, you got positive number. If you take a negative number as the x, you square it, it becomes also positive. So in this case, there's no such number in which you square, you get -1. So however, all right, when you have such equation, so when you want to solve previously, this is where we will say no real solution. Okay, so what mathematician did, all right, long time ago perhaps, all right, they invented, okay, this is what they call a complex number, all right, to take care of this type of equation. Okay, so that means, all right, after this, all right, when you encounter any such equation where you have a square root of a negative number, so that means there is now a solution. But of course, it's not a real solution. But in this case, we say it's a complex, it will be what we call a complex solution. Okay, because it becomes what we call later on a complex number. Okay, so then what actually this mathematician came up with, all right, they invented, all right, that this x equals to -1. Okay, it is actually, okay, from here, all right, that x equal to square root of -1. Then this one they call it as imaginary, okay, imaginary unit, or they would say imaginary number. Okay, and they introduce, all right, that square root, all right, of -1. Okay, they introduce square root of -1 with a letter, all right. In mathematics, all right, we use a letter I. But I think in engineering, because complex number has many application in engineering field, so maybe engineering they use J. They use a letter J. Okay, they use a letter J. Okay, engineering maybe they use a letter J, which represent as the square root of -1. Okay, so whether you encounter in your engineering classes, all right, complex number with the J, all right, don't get confused. All right, it's just a letter, but the rest of are the same. Look at in terms of properties, in terms of what we call the arithmetic operation and so on. So the rest will actually are the same, except for only the representation in terms of letters. Okay. All right. So with this complex number, or with this what they call imaginary number, then it completes actually a number system. If you remember, number system. Okay, number system. When I say of remember, number system starts from last time, maybe you learn about real numbers. Okay, you learn about real number as the top in the list of what we call number system. Okay, real number is actually at the top of the number system. Previously, maybe you learned this. Of real numbers are, just now I mentioned, is all numbers from -infinity to positive infinity. These are what we call real numbers. And then a subset of a real number is where you have what we call last time rational numbers. Okay, rational numbers as well as irrational numbers. Okay? If you remember irrational numbers. So what the difference between rational number and irrational numbers previously, if you recall? Rational number, example of rational number is you have something like a quotient form, a numerator and denominator. Like for example, 1/2. This is actually example of rational number. Characteristic of rational number, use calculator, you will get just 0.5. That's it. Okay. Or another characteristic of rational number, all right, maybe you have something, this is what we call a terminating decimal. Okay, terminating decimal, that's what we call rational number. An example of irrational number is where you have something like pi. Pi is actually what we call irrational number. Or any square root number like square root 2 is a irrational number. Characteristic of irrational numbers is where you have, like they call it decimal number which it is not, is different. Like for example, pi is 3.142, okay, or square root of 2 also, like 1 point something, whatever, where the decimal number, all right, the number after the decimal, you will see the number, actually the digit actually different. It's not like 0.6666. This is what we call are the same. Okay, this one actually it goes to this type of irrational number. Okay, this is only for your understanding, but what I'm trying to say here, previously you learned about number system, and then of course a subset of rational is integer, all right, and then a subset of integer is natural number, then you have a whole number. Okay, so with this complex number now, all right, when the mathematician they invent, and only they said that okay, complex number will be at the top, and that will actually complete the whole number system. So complex number, then it becomes here, it becomes at the top of the system of numbers. Okay, so then this complex number basically, all right, number. Then we have what we call imaginary number. Okay, imaginary number. Okay, so basically your I is here. All right, your I or your square root of -1 is here. Is under the imaginary number. Okay, I is under the imaginary number. So any square root of negative number will belong under what we call imaginary number or imaginary unit, they call it. Okay, so you will have like square root of -1, or you may have square root of -4, or any negative number, square root of any negative number, that will belong under what we call imaginary number. So then this complex number, they mention that it actually completes what we call the whole number system in mathematics. So complex number consists of what we call the real number as well as imaginary number. Okay, and back to this, all right. Okay, so basically, okay, this is actually I. Okay, they introduce I, the letter I. Okay, they introduce the letter I as square root of -1, square root of -1. So when we square both sides, then that's when we have I squared equals -1. So if I equals square root of -1, then I square equals 1, -1. Okay, so this is logic, because when you square both sides, okay, you square both sides. So if you have your I equals square root of -1. So when you square both sides, okay, so that's when you get your I squared equals to -1. So this is logic. And in fact, this is what you also need to remember by heart also, that I equals to square root of -1. So then I square equals to -1. Okay. All right. And then there's a definition here. Perhaps we can go through here, which says that complex numbers are numbers of the standard form of A plus BI. Okay. The word is standard form. Okay, the word is standard form. So that means that is the way we write complex number in standard form. It is in the form of a plus bi, where a and b are real numbers. Okay, a and b are real numbers. A and b are real numbers. The real number a is called the real part. The real number b is called the imaginary part of the complex number a plus bi. So if a equals 0 and b not equal 0, then complex number bi is called a pure imaginary number. Okay, what does it mean from this definition? Okay, so it goes back to this number system just now. We said that complex number consists of real number and imaginary number. Okay, so then this is our standard form. So standard form is in the form of a plus bi. Okay, so that means it means like this. All right, complex number example. All right, this is like this, or you may have like this, or you may have like this. All right, in which what it means. All right, by the definition, standard form of a complex number is written as in the form of a plus bi, where a and b, this is actually is a real number. All right, these are real numbers, and this is also can be called as real part. This is imaginary part. All right, okay. And if a, just now we mentioned that if a equals 0 and b not equal 0, that means you have just this bi like that. Imaginary part. Pure imaginary part means there's no real part. Okay, when you don't have this real part here, only this bi. Okay, only this bi. So bi is just called as pure imaginary part. This is just a terminology.
Madam, you are mute. No, your Webex is mute.
Can you hear me now?
Yes, ma'am.
Yes, madam.
I think
Yes,
something
madam.
wrong
Yes,
with the Webex
madam.
today.
Yeah, because from
Actually,
earlier I cannot see your screen.
yeah, actually it's since yesterday actually. Yesterday is also similar. All right. Somehow. So today, what I was told from someone is that so there's something wrong with the YouTube and Google, something like that. So I think that's why we have this all these technical problems today. So it seems that when my screen got stuck, then I know that you cannot hear me because just now also my screen got stuck. Okay, I cannot move the screen. So when it got stuck, then I know. That's why I asked you whether you can hear me because definitely you can't hear me. Then I need. Okay, so sorry for these issues. There's nothing we can do. It's beyond our control. All right. Okay, let me continue. Okay. Something also still wrong with this. Okay, hold on. Can you all hear me?
Yes, madam.
Can Okay, hold on. I'm trying to share again. Somehow okay. Hold on. Oh, I'm going to exit again one more time, then I'll join. Just hold on. Okay, other platform. I do not know how to actually use other platform.
Uh,
I only, yeah.
maybe you can use Microsoft Teams or
I have Microsoft. I
Zoom
have
meeting.
Microsoft Teams. I have Microsoft Teams, but I Teams.
Madam, you are muted again.
Oh,
Okay, okay, now I
you
can hear you.
cannot hear me. Can you hear me?
Yes, now I can.
Yes.
Can you hear me? Okay, let me try again. Share screen. So something wrong. I think since yesterday got some technical problems. Okay, hopefully this time. Hopefully. Okay. All right. Okay. Okay, can you all see now?
Are you sharing a screen, madam? Because I still not can
You
see.
cannot see.
Yeah,
I've
yeah.
You
already
can
shared my
see, madam.
screen.
It is loading. It's only loading.
Loading.
Earlier,
Okay. Anybody can see?
Ma'am,
yes,
can
madam.
you? Yeah, I can
I
see, ma'am.
can.
You can
Yeah,
see now?
yes. Yes.
Okay, Mia, what about you, Mia?
Okay, now I can see.
Okay, all right. Okay, I really hope that no more issues after this. Okay, but actually it happened also yesterday. After 50 minutes of the lecture, then suddenly people could not hear me, and then my screen also stuck yesterday, and then I have to actually exit and join again. Okay, but it was like one or two times yesterday. Okay, but the thing is, the funny thing is that the one that I record, okay, it actually it doesn't capture the screen. Okay, so there was like no screen for my recording actually yesterday. So I'm not sure today. So I'm trying again also today. I'm also recording my lecture, but I do not know what happened. All right, at the end. Okay, let's continue. All right. So if you can hear me, I think I'll continue with the complex number. Okay. So again, this is what we call complex number just now from the definition. So the standard form, okay, whenever we talk about standard form, so this is the standard form of a complex number. So it is in the form of a plus bi. Okay, so you see this is what we call the standard form of a plus bi. So a is 2, all right, our b is 3. Okay, so this is our a, this is our b, so this is our bi. Okay, so standard form is a plus, so if you have, for example, you may also have example of complex number, maybe something like this, 5 minus 2i. Okay, 5 minus 2i. This is also what we call complex number in standard form. It's just that in this case, your a is 5, your b is minus 2. Okay, so if you have, for example, minus 7 plus 3i, okay, that means a is minus 7, b is 3. Okay, all right, because your standard form is in the form of a plus in the middle. Okay, so a plus bi. So if you have, for example, minus 7i only, this is our pure imaginary. In this case, there's no a, right? So your b in this case is minus 7. Okay, so this is what we call our standard form of a complex number. Okay, then you have actually properties of complex number. All right, properties of complex number. So if you look at the first property, it says that principal square root of a negative number. So you have your square root of minus n equals to square root of n times square root of minus 1, which is equals to square root of ni. Okay, so it means that for complex number, okay, for complex number, for example, square root of negative 1 is understood. This is I. Okay, this is I from the theorem. So if you have, for example, square root of minus 4, it is the same thing as square root of minus 1 times square root of 4. Or you can write it in a different way, square root of 4 times square root of negative 1. So this is your I. This is definitely 2. So then you can write it as 2i. Okay? Or if you have, for example, negative 8. Alright, so then this is the same as, I can write it as like this. Alright, and square root of negative 1 is I. Okay, square root of 8, okay, don't use decimal. In complex number, we don't use calculator and we don't use decimal. Right, so what we do is actually using exact value. Now, most of the time it's exact value. So square root of 8 can be written as 2 square root of 2. Okay, because square root of 8 is 2 times 2 times 2. Okay, so this is the same as, okay, you can write like this. However, it is suggested that every time there's a square root, then write your I in front of the square root. So it is suggested that you write like this. If you don't have a square root, you can write like this. But if there's a square root, it is suggested that you write your I in front, just to avoid, okay? Just to avoid making mistakes, because there's a tendency, if people wants to write, for example, 5 like this, square root of 5i like that, so we're afraid that people may write like this. So when you write like that, okay, sense. Okay, it doesn't make sense like this. Okay, square root of 5i doesn't make sense. All right, so then it is suggested you write I times square root of 5 like this, so that to avoid making mistake, all right, in terms of writing the complex number. But if there's no square root, 8i, okay, minus 7i. Then if there's no square root, then we will write I at the back. If there's any square root, we will write I in front. Okay. Later on also, you will see that when we write in terms of polar form, also it will be the same. Polar form, it requires us to write in terms of cosine sign. So when there's a sine, cosine, also we will write I in front. Okay, to avoid confusion. Okay, to avoid confusion. Okay, that is the first property. The second property, just talk about equality. So equality means, all right, two complex numbers are the same if their real number, real part equals the real part, imaginary part equals to imaginary part. Okay, so that is the second property. Okay, however, the important one is actually when it comes to the arithmetic operation. This is the arithmetic operation where you can add and subtract two complex number. So you can add two complex number. You can also subtract two complex number. So when you add or subtract two complex number, okay, all right, example, all right, maybe there's a product there. Okay, maybe I'll just I need some space. Maybe I'll just erase some of this. Okay, all right, okay, so example for sum. That means, let's say you have two complex number. You have 5 minus 11i plus with perhaps 7 plus 4i. Okay, so you have two complex numbers you want to add. So when you want to add two complex number, this is quite straightforward. Difference also, subtraction also quite straightforward. You will add real part with real part, imaginary part with the imaginary part. So you don't mix with real part with the real part. So in this case, this is our real part, 5, all right, from the first complex number here. The second complex number is 7, okay, the next one. So you just add 5 plus 7, so real part with real part, all right. And then imaginary part, you add with the imaginary part. So in this case, the imaginary part is minus 11i plus 4i. Okay. Imaginary part. So minus basically is the same as minus 11 plus 4. Okay. So minus 11 plus 4. So that means just minus 7i. That's how you add. Subtraction also similar. Okay. When you want to subtract, also similar. So let's say you want to subtract. Okay. This add and subtract just now. Or we can say difference. Okay. Subtract. We can say also difference. Okay. Sum and difference. Add and subtract. Okay. 5 minus 5 plus Okay, minus 5 plus 7i minus, and then minus 11 minus 6i. For example, you have these two complex number you want to subtract. So sum and difference or addition and subtraction is the same. Real part with the real part, imaginary part with the imaginary part. So you don't mix it up. Okay, so you do it separately. So real part minus 5, okay, minus 5, and then you subtract minus 11. Okay, so minus 5 minus 11. So in other words, minus 5 plus 11, okay, which is 6. And then imaginary part with the imaginary part. 7i, okay, 7i minus 6i. Okay, so imaginary part with the imaginary part. 7i minus 6i. So in other words, 7 plus 6. Okay, which is 10 plus 13. So that is how you add and subtract. Okay, it's already like 5 minutes past 3. But so far, any question before we take a break? Any question to ask before we take a break? 5 minutes? Okay, so far okay?
Okay, madam. No question.
Alright, okay, so we'll take 5.
Banyak banget ah.
Alright, we'll take 5 and then we'll continue, okay? After 5 minutes. Okay, can you all hear me? Alright, okay. And can you all see the screen? Can I? I hope you can see the screen. Alright, okay. Can I continue now? Shall we continue? Alright, okay. So let's continue this. Okay, so this is about sum and difference or addition and subtraction of two complex number. So when it comes to addition and subtraction of two complex numbers, you do it separately. Real part with real part, imaginary part with imaginary part. Okay, so you don't mix it up. Okay, so sum and difference can be quite straightforward. All right. However, when it comes to product, okay, when it comes to product, or in this case, a multiplication. So when you multiply, if you want to multiply two complex numbers, okay, so it is no longer like sum and difference just now. It is not like real part you multiply with real part, imaginary part with imaginary part. It is not like that. Okay, so when it comes to a multiplication for complex number, what you need to do, you got to expand. You got to multiply one by one. For example, okay, let's say you are given just 3 minus 5i. This is one example. So what you need to do when it comes to multiplication, you need to expand. You multiply 4i times 3 and then 4 times minus 5i. This is what you need to do. So you got to expand one by one. So in this case, all right, 4i. So that is 12i. Okay. And then 4i times minus 5i. So that is your minus 20i squared. Okay, 4i times minus 5i minus 20i times I, so I squared. However, I squared is understood that this equals to negative 1. I squared equals to negative 1 because I equals to I equals to square root of -1. So I squared equals to -1. So in that case, you have to multiply that -1 to that. You got to multiply this -1 to this. So that means it becomes positive 20. So that becomes real number. That means -20i square is a real part. Okay, it's a real part. 12i is the imaginary part. Okay, this is imaginary part. This is a real part. Okay, so final answer for complex number, you must write in the form of a standard form. Okay, so standard form is your 20 plus 12i. So this is a standard form. So when it comes to complex number, you must write in the form of what we call a standard form. Sometimes question may say standard question, it doesn't mention standard form, but if it doesn't mention standard form, you write also in standard form. Okay, because it is understood and commonly when we write complex number, we will write in terms of standard form. So it means that standard form means real part in front, real part plus imaginary part. Okay, I'll give you another example. Okay, let's say another example. You have this product 7 minus 3i times minus 2 minus 5i. We have a multiplication of these two complex number. So when it comes to a product, you have to expand one by one. This times this. And then this times this. And then this times that. This times this. So you got to expand one by one. Okay, so this is how we do multiplication for two complex number. And definitely when you multiply like this, when you expand, you are bound to get I square somewhere. So whenever it is I square, change that I square to -1. Okay, so let's do this. Okay, so let's do this. So first is 7 times -2. So 7 times -2 minus 14. And then 7 times minus 5i. Okay, 7 times minus 5i. So minus 35i. And then minus 3i. Okay, minus 3i times minus 2. Okay, so minus 3i times minus 2. So that is your positive 6i. Then finally, minus 3i times minus 5i. So minus 3i times minus 5i. So you have your plus 15i square. Okay, so this is the one. You must make sure change that to -1. That means it becomes your minus 15. Okay, so your final answer as a standard form of a complex number. That means real part you add or subtract with the real part, imaginary and imaginary part you simplify. Okay, so minus 14 and minus 15, so that is minus 29. And then minus 35i plus 6i, that also minus 29i. All right, so this is product of two complex number. Any question? Okay. All right, this. Okay. Let's look at this, what we call power of I. All right. This is a product. Okay, this is a product. Later on, we will have a quotient or division. This is a multiplication. Just now is a addition, subtraction. This is multiplication. Later, we will have also division. But before we look at division, let's look at what we call power of I. Okay, if you look at this, that is actually is a pattern. That's a pattern. Okay, all right. Of course, I power 1 is I. Alright, I power 2 is minus 1. I power 3 is actually is I squared times I, which is minus I. And then I power 4 is I squared times I squared equals 1. And then the list can goes on and on. So actually there is a pattern actually. Alright, there's a pattern. Okay, and along the way, later on you will see in the question in the book also, they will also ask you to evaluate I with a power. Okay, they will ask you to find I to a certain power. Okay, now to find that or to evaluate I with power, all right, it is not so much on memorizing all this. No need to memorize actually. But before you can do that, perhaps you need to actually recall. You need to recall one thing. You need to recall what we call rules for exponent. Okay, what are rules for exponents? Okay, there are several rules for exponent, but the most important one for this understanding is actually something like where you have, for example, if you have b power m multiply by, then remember power you are going to add m plus n. Okay, b is what we call base. Okay, base, when the base are the same, when you multiply b to power m multiply by b power n, then you are going to add powers. And another rule that you have is if you have b power m and then the whole thing to power n, you raise again to another power n. This is the case whereby you will have b power, okay, exponent, the power becomes a product. You multiply m times n. Okay, m times n. So these are the two rules that it is important for you to understand in order for you to actually evaluate or to find I to certain powers. Okay, even if you look at this, all right, you look at this one, like I power 3 is I squared times I, actually is using this rule. Okay, using this rule. All right, using this rule, like I power 4 is I squared times I squared, it actually is using this rule. Okay, all right. Okay, so if let's say for example, okay, for example, question asks you, okay, I think someone you unmute your mic, is it Shafiq? Okay, all right, let's say question asks you to find or to evaluate I power 20. Okay, find I power 20. All right, first basic understanding is about, instead of I equals to square root of minus 1, you also have this, right? Which is I squared equals minus 1. Okay, so when I squared equals minus 1, if you look at this one, okay, I power 4, isn't that I power 4 is actually from I squared times I squared, which is actually positive 1. So I power 4 is positive 1. Okay, I power 4 is positive 1. So if you have a question where they ask you to find certain power of I, it is actually the guideline is where you try to find a multiple of 4. Okay, find a multiple of 4, because the fact that I power 4 is 1. Okay, all right, or I squared equals minus 1, then I power 4 is 1, then it is actually good if you can just try to find a multiple of 4. Okay, when I say a multiple, oops. Okay, when I say a multiple of 4, okay, a multiple of 4 means you try to find like start with I power 4 first. I power 4, and then you want to multiply by what? Okay, and you also need these two concepts here. You can either use this concept or use this concept. Okay, so maybe, all right, for this I power 20, all right, I can say that perhaps it will be I power, I'll start with I power 4. Okay, now instead of I'll do like this. Okay, if I say I multiply I power 4, this one it could be like you have a longer way to go, because if you do like this, I power 4 times I power 4, then means that now this is only I power 8, because power you add. Okay, you use this concept. Okay, so to do this faster, perhaps I'll try to use this concept. I apply this concept, then it'll be a bit faster. All right, using that multiple of 4, because if I'm using this like this is only like I power 8. I want to come to like 20 here. Okay, so perhaps instead of times with I power 4, maybe I will try to like the whole thing I raise to power 4 and see. As long as it doesn't go beyond 20, all right, I'm on my right track. Okay, because if I write like this, that means it will be I power. Okay, I'm using this. Okay, so that means I'm going to multiply powers. If it is like this, it means power we multiply. So that means if that's the case, if I do like this, all right, if I do like this, I start with I power 4, I raise to another power 4 again, which means I have I power 4 times 4, which is, I'm talking about I power 16. Okay, I power 16, still less than 20. And to get to 20 from 16, that means 16 just add with another 4, isn't it? 16 plus 4 is 20. So if I want to plus 4, I want to add with 4, that means I multiply I to power 4 like that. So if I do like this, that means then only this one becomes 20, because then this means I'm using this concept, this rule. Okay, so then it becomes I20. So which means, all right, for this question, if I want to answer, all right, if I want to answer for my I20, that means I have here multiplied by I power 4. That means my working is like that. It's I power 4, and then I raise the whole thing again to power 4. So then this one is I power 16. I multiply by I power 4. So 16 plus 4, then it's 20. So which means now, because I know that I power 4 is 1, right? I power 4 is 1. Or in other words, I know that I squared equals minus 1. So I power 4 is I squared times I. So which means in this case, right, I power 4 is my 1. Of course, I raised to power 4 is still 1. I multiply by also 1. So it means my answer is positive 1. That is my I20. Can you all follow? I'll give you another example. Okay, this is for I20. I'll give you another example, but can you all follow? Any questions so far? Another example. Let's say you want to find I power 50. Okay, I power 50. Let's say you want to find I power 50. Okay, try also start using I power 4. Okay, so try with the multiple of 4. Okay, so that means I power 50. If I start with I power 4, all right, try with the multiple of 4. Okay, I raise again to power 4. Now it becomes I power 16. Okay, so 16, still less than 50. Okay, what else can I raise to? If I say I raise to power 4, let's say I raise another 4. Okay, then 16 I times 4, right? So if 16 just now, this one 16, this two is 16, 4 times 4 is 16. So if I do like this, that means I multiply again by 4. So if I multiply by 4, 16 times 4 is what? 16 times 4 is 64. 64 is already exceed 50, so cannot, so not 4. So outside here cannot 4. So if 4 means I go beyond 50, so try with 3. So what about 3? If I try by 3, okay? So 16 times 3. 16 times 3 is what? 48, isn't it? Okay, 6 times 3, and 18. 3 times 1, 3 plus. So in this case, I still have I power 48, like this. So I just need another 2, isn't it? To get to 50. 48 plus 2 will be 50. So that means I just multiply by I square. So then I will get my I power 50. So which means I'm going to multiply by I power 2. So this is the step. Okay, so that means I'll start with I power 4. I raise the whole thing to power 4. And then I raise again the whole thing to power 3. Then I multiply by I squared. Okay, so that means, okay, these two actually, you can also write as like I power 4 power 12 also can. Okay, you can also write like that. Okay, this one you can combine if you want. Okay, it becomes 12 also can. All right. So that means you can also write like this. I power 4 you raise to power 12 also can. Okay, because it's the same thing. Okay, so then I power 4 again is 1. So you raise to power 12 also is still positive 1. However, what is I square? I square is minus 1, right? Because I minus 1, so I square is minus 1. So in this case, the answer is minus 1. So I power 50 is minus 1. All right? Okay? Okay, that is all about finding power of I. Okay? Any question? I hope you can all understand this. You all can follow this. Okay, next terminology. Okay, this is another terminology. Conjugate of complex number. Okay, I hope that you ring a bell, the word conjugate, what it means. Okay, when we learn about something with the radical last time, okay, when we did our trigonometry, when we have expression with the radical, then we said that we multiply by conjugate. When we want to rationalize, remember, rationalize our denominator expression with a radical, we said that we multiply by conjugate of denominator. So the word conjugate is the same thing for here. It means that last time the difference, all right, between conjugate and the original expression is by the sign, plus minus sign. So here also similar. If you look at this expression, sort of like definition, all right, it mentioned that if let z equals a plus bi is a complex number, then its conjugate denoted by z bar. Okay, z bar is a notation for conjugate, is defined as this, a minus bi. Okay, so conjugate notation is with a bar. So if you have z is a complex number, okay, z bar means is conjugate. conjugate of Z. This is what it means. Okay, that's notation. All right, so if A plus BI is a given complex number, all right, so if you have like this, A plus BI means conjugate of A plus BI, which is, what is the conjugate? It will be A, oh sorry, okay, maybe I'll write like this. It means it will be A minus BI. So that is the conjugate. So the difference is that minus in the middle. Okay, so this is what it means by conjugate. Or if you are given the other way around, all right, let's say you are given, for example, A minus, given, for example, given like this, or like this, fine. Maybe I'll write somewhere here. I'm running out of space. All right, fine. Minus plus 3i with a bar like this. Question gives you like that. Find that. That means, what's the answer? Okay, Adelina. Yes, Adelina, you have a question? Adelina, do you have a question? You raise your hand.
No, madam, sorry.
Okay. All right, okay. So if question say find that with a bar, all right, minus 2 plus 3i with a bar, that means they're asking you the conjugate. Find this. So that means that is actually is minus 2 minus 3i. Okay, so this is what it means. All right, so if you have, for example, maybe I erase this. Okay, I erase this. Okay, and then maybe example here. So you have your complex number. All right, complex number, and then here is conjugate. Okay, let's say if you have, for example, 5 plus 7i. So conjugate would be 5 minus 7i. If let's say complex number is given as minus 11 plus 3i. So conjugate is minus 11 but minus 3i. So the difference is only the sign in front of the imaginary part. If it is given as minus 2 minus 5i, so then conjugate is minus 2 plus 5i. So this is what it means by conjugate. Okay, and again, the notation sometimes they are using with a bar. Bar means conjugate. Okay, so why you need to understand this? Because then it leads to another theorem, important theorem, which is about a product of complex number and its conjugate. Okay, Z times A minus BI. Now look at the formula here. Okay, look at the formula here. A plus BI times A minus BI, you get this formula, A squared plus B squared. Okay. You remember when you learned about multiplying two conjugate expression last time with real number? If you're talking about real number, okay, you're talking about real number, you have A plus B times A minus B. So last time you have A squared minus B squared. This is for real numbers. Okay, this is for real numbers last time. However, when it comes to complex number, so you have now with the I. So in this case, all right, actually, you get actually same thing. It is actually it's the same thing. It's just that now your B is the BI squared. Okay, it's the same expression. But because of the BI squared, because of then it becomes I squared. All right, that this is minus B squared I squared, and because then I squared is minus 1, that's why it becomes now A squared plus B squared. So that's why you have this. Okay, so actually it is the same concept. All right, similar this real number, but because when you have the I square here, so that's why you have A square plus B square. Now, if you forgot, if you don't remember this, okay, if you don't remember this, how can you get this? How can you get that? Actually, this is actually gotten from expanding, because this is a product, because this is a multiplication of two complex numbers. So basically you are expanding terms. Okay, like when you did your multiplication just now, you expand terms, so you got actually A squared plus B squared. So if you don't remember the theorem, you can just expand. But if you understand that when you have a product of a complex number and its conjugate, you can actually do this faster by using this. Okay, by using this. Okay, for example, if let's say, all right, let's say we give you, for example, multiply 2 plus 3i plus 3i. All right, you got this question, and when you look at the question, you understand that these are conjugates of each other. They are conjugates. So if you understand that these are conjugate, you can do this faster by using the theorem A square plus B square straight away. A is 2 plus B is 3. Don't take minus, don't take minus 3. This is just 3. So just 3. Positive is 3. All right. So quickly you can straight away get your answer. But if let's say you forgot or you confused, okay, you're not sure, then I would suggest you expand. 2 times 2, 4, and then 2 times minus 3i minus 6i plus 3i times 2 plus 6i plus 3i times minus 3i, so minus 9i square. Then only, you know, again this one minus 1 and minus 6i and 6i cancel. So then you got 4 plus 9, which is 13. You got the same answer as well. Okay, so again, if you notice that you have a product of two complex and they occur in conjugate pairs, they are conjugate of each other, either you straight away compute like this, or if you are not sure, then you got to expand like you do the multiplication of two complex number. Okay, right? And you can see, you can see from here also, all right, when you can see from here also that when you multiply two conjugate expression, what you have is actually what they call a non-negative real number. Non-negative real number. The product of a complex number and its conjugate is a non-negative real numbers. What does it mean by non-negative? Non-negative means positive. Okay, positive real number. It will always be positive because why? Because you square. You have A square plus B squared. So it's a sum of squared numbers. Definitely the whole thing is positive. You cannot get negative number. It will always be positive number. So that's why it says non-negative real number. Okay. All right. Okay. So any question? All right. So then with that understanding of a product of two complex number, then you can actually proceed to the next arithmetic operation. Before you do the division, okay, before you do the division, there is what they call a reciprocal of complex number in standard form. Reciprocal means you are given a reciprocal of complex number 1 over a complex number. Okay, reciprocal means 1 over a complex number. So you have like this, 1 over a plus bi. All right. So if you are given a reciprocal of complex number, question will definitely ask you to write that reciprocal in a standard form. Standard form is in the form of. So how to do that? This is where the case you need to multiply by the conjugate expression. Okay, this is like rationalizing, like the concept of rationalizing the denominator of the square root last time that you learned. Okay, so if you have a reciprocal, you got to rationalize by multiplying the conjugate of the denominator expression. Okay, for example, okay, let's say you are given just one reciprocal expression. Okay, let's say question asks you express 1 over, let's say 2 plus 3i in the standard form. Standard form of a plus bi. Okay, so that means, all right, you start with 1 over 2 plus 3i. Then you need to multiply by the conjugate expression of that denominator. So conjugate for 2 plus 3i is 2 minus 3i. So both numerator and denominator. Okay, so this is the concept of last time, rationalizing the denominator. Remember last time when you have a set 1 over set 2 last time. So how do you rationalize? You multiply by set 2 over set 2. Why do you want to rationalize last time? Because you want to be able to write your denominator expression without square root. Just one real number without a square root. That's why you do that. Okay, you say rationalize. So same thing here. All right, same thing here. When we say that we rationalize means we multiply by the conjugate. Why we need to multiply by conjugate of this? Because we have understood from previous that when we multiply two conjugate expression, all right, we will get one real number. No more complex, all right, no more complex number. It's a real number. So that means our denominator will be real number in this case. Okay, so the concept is actually similar to this. Okay, all right. So when we do this, all right, we can proceed this. That means our denominator, okay, numerator, you got to multiply. In this case, you just have 1 times 2 minus 3i. So that means your numerator in this case is just 2 minus 3i. However, denominator, just now, if you know that this is a conjugate expression, both are a product of conjugate, so straight away a square plus b square. So a square plus b square, so then this is 2 minus 3i over 13. All right, then just one more step to write in terms of a standard form in the form of a plus bi. This is the standard form. So that will be your last answer. So you cannot, don't leave your answer here. Don't leave answer here. This is not yet in standard form. Okay, this is not yet standard form. Standard form is until here in the form of a plus bi. So Standard form means you have your real part and imaginary part. Okay, all right. Okay, so this is, we call it a reciprocal, all right, a reciprocal expression. From the beginning, you are given a reciprocal expression and question asks you to find the standard form of A plus BI. Okay, then it leads to another, this is the last arithmetic operation. Okay, last, so you have done just now the addition, all right, subtraction, multiplication. Okay, now this is what we call division or quotient, all right. This case is division. Okay, division of a complex number. So if you look at division of a complex number in this case, all right, so you have one complex number C plus DI divided by A plus BI. So how do you divide two complex number? By multiplying by its conjugate, both numerator and denominator. That means if you want to do complex number, it is the same thing. You rationalize the denominator of that complex number, the given complex number. This is what it means. Okay, because by rationalizing, then only your denominator becomes just one real number. Then only you can write in a standard form, like just now, the reciprocal. Okay, all right, so to make sense, all right, maybe I'll give you example. Okay, okay, divide 7 plus 4i by 2 minus 5i. So you have these two complex number. So divide this one complex number by that complex number. Okay, so which means that it is the same as to ask you 7 plus 4i divided by 2 minus 5i. This is what it means. So to divide this means, okay, divide means you are going to multiply by, okay, conjugate expression of the denominator for both numerator and denominator. So this is what you need to do. Okay, so you multiply by conjugate of denominator expression. Okay, conjugate of this denominator. Okay, not conjugate of this, not conjugate of numerator. It is conjugate of the denominator. If you rationalize numerator, you cannot still write in terms of A plus BI. You can only write A plus BI form in when you multiply conjugate of this denominator. Okay, so division means you write expression. Okay, so then, all right, it becomes, okay, numerator, definitely it is a product of two complex number which are different, not conjugate expression. So in this case, you got to expand one by one like you did just now, product of two complex number. However, denominator expression, because you can see both are conjugate pairs, they are conjugate of each other, you can straight away use 2 squared plus 5 squared. Okay, A squared plus B squared. Right? Okay, so numerator to expand one by one. 7 times 2, okay, 7 times 2, okay, 14, and then 7, and then 7 times 5i, okay, 35i, and then plus 4i times 2, okay, all right, and then finally 4i times 5i. Okay, denominator just 4 plus 25. Okay, then you simplify numerator. Don't forget you have your I squared here, all right, which is -1. So don't forget that. So then it becomes 14 minus 20. So then it becomes minus 6. All right. Okay. Can I straight away write this as A plus BI? Or maybe I'll, okay, never mind. I write first -6 plus, okay, then 35i plus 8i. So that is 43i over 29. Okay, then only finally I write in the form of A plus BI. Okay, maybe I'll show you this these portraits so that you can see the whole thing. All right, it's a portrait form. All right, okay, so that is how we do the division of two complex numbers. Okay, and then you have a bottom part here. This is just to say a property. Z bar. Z is a complex number. Okay, so you have Z. You get, or if it is Z plus W, the whole thing with the bar, that means okay, is a conjugate of the sum. It is the same as you add separately conjugate. This is what it means. Similarly, mention here that the conjugate of the two conjugates. This is what, okay, this down here property. Okay, but this is all the division. Up here is all the division. Okay, this is all the division part here. All right, this is all division. Any question for the division? So basically, what we have introduced you today is on a complex number itself. Okay, the difference between what we call the real part and the imaginary part, and then the definition of I, which takes the value of square root of -1. Okay, so therefore I squared equals to -1. And then you have all these arithmetic operations on complex numbers, namely addition, subtraction, multiplication, and division. And you have seen that for addition and subtraction, it's quite straightforward. You just add and or subtract real part with the real part, imaginary part with the imaginary part. You don't mix it up. But product, for multiplication, you expand terms one by one, you multiply. Okay, it's like you're expanding the terms, multiply one by one. And don't forget, along the way, there'll be like I square. So you change I square equals to -1. And for division of complex number, like this one, division of complex number, this is where you need to what we call rationalizing. Okay, you rationalize the denominator expression of the complex number. Okay, this is how we do the division for two complex number. Okay, so I think that I'm going to stop here. All right. So then maybe next week, then I will continue with some other parts. Okay, so this is our basically our first part of the complex number. Any question? Any question? Okay, for tutorial this Thursday. Okay, so I am going to actually later I will come up with a list of names, all right, whom I would like you to again submit the solution like last time we did. Okay, so that one I think I will do it that later. I will post that into group WhatsApp, our WhatsApp group. Okay, so for both our morning session, Thursday morning session, as well as our Thursday afternoon session. Okay, so those are for Thursday morning. I would like to receive your solution, perhaps Wednesday, maybe Wednesday evening, Wednesday afternoon. Maybe for the Thursday session, you send me on the Thursday morning itself. Okay, so then I will not get confused as who to actually send me which one for which section. Okay, is it understood? Any question, class?
Madam, can you repeat it again about the exercise?
Okay, this is for tutorial. Okay, for tutorial on Thursday. All right, I'm going to, again, like last time, I will write down names, for which question. All right, this question is whom. All right, then I expect those people, they send me earlier. All right, before, of course, before the session, before our tutorial session. So for section 1 and section 1/1 and 1/2, which you have your tutorial on Thursday morning. So you send me your solution by Wednesday evening. Okay, Wednesday evening. Tomorrow, that means tomorrow evening. However, those for your tutorial session is on Thursday afternoon. Then you send me that solution on Thursday itself, Thursday morning itself. Okay, because I do not want to get mixed up, okay, with your solutions. Is it understood? But I haven't, I'm going to post the name in our WhatsApp group later. Okay, then only after I've sent, then only you see whom I actually assign the question. All right, that you need to send me or submit me the solution. Okay, for our discussion during tutorial. Okay, this is actually our tutorial this week is regarding our chapter 3. Okay, our chapter 3, which is our application of trigonometry. Even though you already have your assignment questions, all right, which also consists of chapter 3, okay, but you still need to do questions in textbook as well, because we still have tutorial session to discuss. We still need to discuss some of the question, okay, if not all, we still need to discuss. So that means you still need to do tutorial questions, okay, questions in the module or in the textbook. Okay, is it understood or it's not clear? You need my clarification again? Anyone?
Understood, madam.
All right, okay.
Understood, madam.
Okay, any question before we end the session? Do you all understand about complex number, or do you understand what you have learned today?
Yes, madam.
Okay, I really hope you do. All right, and definitely this complex number will be out for the final exam. Okay, this one will be coming out for final exam. All right. Okay. All right. So if there's no question, then perhaps we can, I think we can end the session now. All right. And thank you for your listening. Thank you for your patience, and sorry for any technical problem just now. All right.
Madam.
All right.
Madam.
Okay. Thank you. All right.
Thank you,
Madam.
madam. Assalamualaikum.
Madam. Welcome. All right.
Thank you, madam.
Thank you. You're welcome.